Good morning, students. This is Anjali, Assistant Professor, Department of CSE AIML, IARE, Hyderabad. Today, we are going to learn about the sampling distribution. In last session, we have learned about the point estimation. In point estimation, we have we have estimate the sum result. That means you are getting some particular result. You are estimating the result by using the population parameters for particular sample. That means it is a point estimation. In point estimation, you are finding out the particular result by using the population parameter, and for that purpose you are using a sampling. And what is meant by sample and what is meant by population, we have already seen that one. And in the population parameter, you are using sample for finding out particular result, for finding out the particular conclusion. And in point estimator formula, you have find out the statistic random formula point estimate. That means you are using the statistically, you are finding out the statistic, and by using the static formula, it is easy to find out the standard deviation, variance, mean, median. These all things are very important. And when we are talking about the statistics, in statistics, both the point estimation and hypothesis are very important. Both things are very important. We can't avoid it. So here you have to find out the point estimation by using particular sample for a particular sample. So now we will start our main course, and we will see the which content we are covering here. Introduction of sampling distribution. How does sampling distribution works? Significance, importance of sampling distributions, and central limit theorem. These topics we will cover. First, introduction of sampling distribution. Students, you know already the sample. What is mean by sample? Sample means just we have to select from the population. That is your sample. And sampling distribution is related to probability distribution of the statistic which is obtained from the larger number of samples drawn from a specific population. That is your sampling distribution. And the sampling distribution of the given population is the distribution of the frequencies of a range of different outcomes that could possibly occur for statistic of the population. If that means every time your frequency, distribution of the frequencies are changing, and all these things are totally depends on your population. What is your population? On that basis, you will get the different frequencies, different ranges. And in statistics, population is the generally entire pool from which a statistical sample is drawn. And the population may refer to an entire group. I already told that the population is an entire group. That could be entire group of the people, entire group of objects, entire group of events, then hospital visits and measurements. All these things are the population. But population can thus be said to be aggregate observation of the subjects grouped together by common feature. Now let's understand what is meant by particular sampling distribution. A lot of data drawn and used by the academician, statistician, then researchers, marketers, analysts. All these are actually samples, not a populations. What I said? Samples. Academician, statisticians, researchers, marketers, analysts, all these are samples. And a sample is your subset of the population. Just we will take the example, a medical researcher that wanted to compare the average weight of all babies born in North America from 1995 to 2005 to those born in South America within the same time period cannot draw the data for the entire population of a million childbirths that occurred over the 10-year time frame within the reasonable amount of time. That means here we have to compare the average weight of the babies which are born in North America from 95 to 2005. And they will instead only use the weight of hundreds babies in each continent to make the conclusion. So, the weight of the 100 babies is used as the sample. Weight of the 100 babies is used as a sample, and the average weight of calculated is the sample mean. Your average weight will be sample mean. And this weight of the 100 babies is your sample. So now suppose that instead of taking just one sample of 100 newborn weights from each continent, the medical researchers takes a repeated random sample from general population, and they will compute the sample mean for each sample group. Now, so for North America, they pull up the data for 100 newborn weights recorded in the US, Canada, and Mexico, and 400 sample from select hospitals in the US. Then 570 samples from Canada and 150 records from the Mexico. And now we have the total 1200 weights of the newborn babies grouped in 12 sets. 12 sets. That means how? 400 sample we take from the US, 5 sets for 570 sample we took from the Canada, and 150 records from the Mexico, and now we have the 1200 weights of the newborn babies grouped in the 12 sets. Now let's say they collected sample data of 100 birth weights from each of the 12 countries in the South America. And the average weight computed for each sample set is a sampling distribution of the mean. Not just the mean can be calculated from the sample. Other things also we can calculate from that sample. Which other things are? That things are the standard deviation, variance, proportion, and range. These things are calculated from that sample data. And the standard deviation and the variance measure the variability of the sampling distribution. And a number of observations in the population, number of observation in sample, and the procedure used to draw the sample sets determine the variability of the sampling distribution. Now, the standard deviation of the sampling distribution is called the standard error. If you find out the standard deviation, so at that time, it is called the standard error. While the mean of the sampling distribution is equal to the mean of the population, the standard error totally depends on your standard deviation of the population and the size of the population and the size of the sample. Now, the mean of the sampling distribution is generally equal to the mean of the population, but your standard error on the standard deviation is totally depends on your standard deviation of the population, then size of the population and the size of the sample. But knowing how spread apart the mean of each of the sample sets are from each other and from the population mean will give an indication of how close the sample mean is to the population mean. And the standard error of the sampling distribution decreases, the standard sample size increases. Now what I have said that the standard error of the sampling distribution increases, sample size will increases. Now what is mean by sampling distribution? The sampling distribution refers to probability distribution statistics that come from choosing a random samples of the given population. And it is also known as the finite sample distribution. And it represents the distribution of frequencies on how spread apart various outcome will be for a specific population. That means sampling distribution is the population distribution of the statistics, from where we will select the particular sample. And it is also known as the finite sample distribution, which is representing the frequencies like how spread apart various outcomes will be for the specific distribution. And the sampling distribution is totally depends on the multiple factors, and those multiple factors are statistics, sample size, sampling process, and the overall population. And these things will help calculate the statistics such as means, ranges, variances, and a standard deviation for the given sample. Now here you can see that the diagram of the sampling distribution. This is showing the probability. On y-axis there is a probability and on x-axis there is a mean. So we can see that this is your sampling distribution. Now, how does it work? First, you have to select the random sample of specific size from the given population. Now, just for example, you have a population and you have to consider the researchers. So, what you will find out the particular group of the researchers, that is your sample. And after selecting any sample, you have to calculate the statistic for that sample, such as you have to find out the mean, you have to find out the median, and then you have to find out the standard deviation. Now develop a frequency distribution of each sample statistic that you calculated from the step above. And now after developing the frequency distribution, you have to plot the frequency distribution of each sample statistic that you develop from the step above. That means here every step is related to each other, and the resulting graph will be sampling distribution. At last you will get the sampling distribution. First, you have to select the random sample with the specific size. Then you have to calculate the mean, median or standard deviation. After that, you have to develop frequency distribution of each sample statistic, and then you have to plot the frequency distribution. After that, you have to draw and at the last you will get the sampling distribution graph. Now, what are the different types of the sampling distribution? First one is sampling distribution of the mean. As shown from the example above, you can calculate the mean of every sample group chosen from population and plot out all the data points. Now here You can calculate by using the sampling distribution of mean. You can calculate the mean of every sample group. Which sample group, that means you have already selected from the population, and now you have to plot all the data points, and the now graph will show the normal distribution, and the center will be the mean of the sampling distribution, which is the mean of the entire population. If you will draw that points, if you will plot that points, so you will get the normal distribution, and whatever the points are in the center, so that are the sampling distribution. So then sampling distribution of the proportion. This gives the you information about the proportions in the population. In sampling distribution of mean, it gives the information about the mean. In the sampling distribution of proportion, it is giving the information about the proportions. And you will select the samples from the population and get the sample proportion. The mean of all sample proportions that you calculate from each sample group would become the proportion of the entire population. Now third one is a T distributions. T distribution is used when sample size is very small. So here the sample size should be small or not much is known about the population. That means that parameter should be unknown. Your sample size will be small, your parameters are unknown, and it is used to estimate the mean of population, confidence interval, statistical differences, and linear regression. With the help of T distribution, you can find out the confidence interval, statistical differences, then linear regression. We can estimate. The T distribution uses generally T-score to evaluate the data that would not be appropriate for normal distribution. And the formula for T-score is T is equal to x minus mu divided by S divided by square root of n. In the formula, x is your sample mean. X is your sample mean. Mu is your population mean. Sample mean is your population mean, and signifies the standard deviation. Now, we will see the significance. This type of distribution plays a vital role in ensuring the outcome derived accurately represent the entire population. However, reading or observing each individual in a population is very difficult. So therefore, selecting samples from the population randomly is an attempt to make sure the study conducted could help understand the reactions, responses, grievances, and aspirations of the chosen population in the most effective way. And the method simplifies the path to statistical inferences. Moreover, it allows the analytical consideration to focus on statistic distribution rather than mixed probabilistic spread of each chosen sample unit. And this distribution eliminates generally variability present in the statistics. If the variability is present in your statistic, then it will eliminate by using this distribution, and it provide us with the answer about the probable outcomes which are most likely to happen. And after eliminating that variability, you will get the particular outcome probable outcomes. So in addition, it plays a key role in inferential statistics and makes almost accurate inferences through the choosing a sample representing the population. If you choose the sample particular correct one, so you will get the particular output, particular conclusion. Now let's take the example. Let's us consider the following example to understand the concept better. Sarah wants to analyze the number of teens riding a bicycle between two regions of 13 to 18. Now, instead of considering each individual in the population of 13 to 18 years of age in two regions, she selected 200 samples randomly from each area. She selected 200 samples from each area. She didn't take any particular person. Selected some sample randomly, and now she will do some experiment on them. Now here the average count of the bicycle uses, here is your sample mean. Each chosen sample has its generated mean, then its own distribution. For average mean is a sample distribution, and the deviation obtained is termed as the standard error. That is the standard error. Then she plots the data gathered from a sample on a graph to get a clear view of the finite sample distribution. Now this is your sampling distribution on the given data. Now let's say second example. Now researchers Samuel conducts a study to determine average weight of 12-year-olds from 5 different regions. Now he decides to collect the 20 samples from each region. Now he decided 20 samples to collect the 20 samples from each region. Firstly, researcher collects 20 samples from region A, and he find out that mean of those samples. Now then again he repeats the same for region B, region C, D, E, and to get a separate representation for each sample population. Now researchers collect the 20 samples from each region, and that regions are A, B, C, D, E. And he collect the samples from each region. And now he get the separate representation for each sample population. And the researcher now computes the mean of the finite sample distribution after finding the respective average weight of 12 years old. And now in addition, again he calculates the standard deviation of the sampling distribution and the variance also. Now again take another example. Suppose you want to find out the average height of children at the age of 10 from each continent. Now you take random sample of 100 children. Now we will consider 100 sample of 100 children from each continent. And now you have to compute the mean for each sample group. For example, in South America, you randomly select data about the height of 10-year-old children. And after collecting the data, you calculated the mean for 100 of the children. You also randomly select data from the North America and calculate the mean height for 10-year-old children. Now as you continue to find the average heights for each sample group of children from each continent, you can calculate the mean of the sampling distribution. You can calculate the mean sampling distribution by finding the mean of all average heights of each sample group. Now not only can it be computed for the mean, but it can also be calculated for other statistics such as standard deviation and variance. By using this sampling distribution, it's not mandatory to compute only mean. By using the same sample, we can calculate the standard deviation also and variance also. It depends on you and it depends on the question what is asking. So you can find out the mean, you can find out the standard deviation, and you can find out the variance also. Now, importance of using a sampling distribution. Since populations are typically large in size And it is important to use a sampling distribution so that you can randomly select the subset of the entire population. Population means it's your group, and sample is a specific group, specific value. And doing this thing, it helps eliminate the variability when you are doing a research on gathering statistical data. And it also helps data easier to manage and builds a foundation for statistical inferencing, which leads to making inferences for whole population. And understanding the statistical inference is very important because it helps individuals understand the spread of frequencies and what various outcomes are like within the data set. Now we will see the central limit theorem. The central limit theorem helps in constructing the sampling distribution of the mean. By using the central limit theorem, you can construct the sampling distribution of the mean, and this theorem is giving the idea of how the shape of the sampling distribution will be normalized as the sample size increases. If your sample size increases, how your sampling distribution is affecting, this will explain in the central limit theorem. And in other words, plotting the data that you get will result closer to the shape of the bell curve the more sample groups you use. And the more sample groups you use, the less variable means will be for the sample groups. When the sample size increases, your standard error will decrease. Therefore, the center of the sampling distribution is fairly close to the actual mean of the population. The central limit theorem helps in constructing the sampling distribution, and this theorem is saying that normal distribution is totally depends on the sample size, and the number of sample group increases, the number of variable standard error decreases. What this theorem is telling that your normal distribution is totally depends on your sample size. What is your sample size? On that basis, your normal distribution is depended, and the number of sample group. If number of sample group increases, the number of variable or standard error will decrease. And to determine if your sample group is large enough, consider the following things. First, it will contain the accuracy requirement. It will check for the accuracy requirement. The most accurate sampling distributions have enough mean data sampling to create the bell curve. And you know very well that whenever you have to find out, you have to plot the data, you have to use the bell curve. To the closer to normal distribution, the visualization looks when the plotted, the more accurate, and the more data is better for the accuracy of the sampling distribution. Now the starting population's shape. First of all, accuracy requirement. Second is the starting population shape. If the starting population closely resembles the normal distribution, bell curve sampling may be required to plot the shape in a sampling distribution. That data we are showing in the bell curve. And data scientists generally assert the data between 30 to 50 data points are enough for making the sharply normal distribution. However, if the population is abnormal, for example, skewed one way or another, you may need more sample for getting the desired result from the sampling distribution. So these are our central limit theorem, and there are some deterministic. So we have seen accuracy requirement and the starting population's shape. Now factors that influence sampling distribution. You can measure the sampling distribution variability either by the standard deviation, which is called the standard error of the mean, or population variance, which are depending on the context of the references you are trying to draw. So both are mathematical formulas that will measure the spread of the data points in relation to the mean. And there are three primary factors that influence the variability of the sampling distribution, and these three factors are the number observed in the population, number observed in the sample, and the method of choosing the sample. First, we will see the number observed in the population. The number observed in population is the symbol for this variable is n. We will denote as a n, and it is the measure of the observed activity in the group of the data. Then number observed in the sample. The symbol for this variable is a small n. For population, we use the capital N. For number of observed in the sample, we use the small n, and it is a measure of observed activity in random sample of the data that is a part of the larger group. Then the method of choosing the sample. Now you have to choose the sample. How you choose the samples can account for variability in some cases. Now we will see the example of sampling distribution. Here is an example of sampling distribution using a fictional scenario with the data set and a graph. A professor is interested in understanding the sampling distribution of their students' test score. This professor thinks this may help determine a suitable curve for the previous test their students completed, and the professor recorded test score from the previous 3 tests and created the data table and a sampling distribution graph. See, you can see that professor took 3 tests. They have stored the score of the students, and they have drawn the sampling distribution graph. You can see here, this is your student test score and how much score got. This sampling distribution shows the professor to their students, and the students' score have a mostly normal distribution with the mean around the 76 to 80%. This is all about the all about the sampling distribution. In sampling distribution, we have covered so many things. Sample distribution, then it's some practical example. Then we have covered the importance of the sampling distribution, central limit theorem. And in central limit theorem, we have seen that all things are related to each other. Here, this theorem is giving the idea about the constructing the sampling distribution of the mean. Then it will tell how the shape of the sampling distribution will be normalized. And again, we have seen the sampling distribution is fairly close to the actual mean of the population. Then again, we have seen two methods, two things which are related to central limited theorem, accuracy requirement, and the standard population shape. Then we have seen some factors of the sampling distribution, and in sampling distribution we have seen number observed in the population, the number observed in the sample, and the method of choosing the sample. This is all about the sampling distribution. These are some references. Next topic we will cover in the next session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.